When the board is lying flat, the pipe doesn't roll. It is being held there by static friction. The pipe will be held in place until it's raised to a certain angle where the maximum static friction occurs. As we raise it past this point, we can see the pipe start to move. This is the static friction being replaced by kinetic friction. In this free body diagram, we can see that there are three forces acting upon the pipe. Static friction, which prevents it from sliding, a normal force of the surface pushing up on the pipe, and the weight force, which is found by multiplying mass and the free fall acceleration constant. The static friction coefficient equation can be found by applying Newton's second law, shown here. The pipe is stationary so that there is no acceleration, therefore the net force is equal to 0. This equation was then put into component form. Based on the free body diagram, the x and y components of the weight can be expressed in terms of sine theta and cosine theta. Known values were substituted into the equation to get these circled equations. We solved the x component equation for static friction and the y component equation for normal force. The static friction can be set equal to the static friction maximum since the forces will be equal right before the object moves. Static friction is substituted by mg sine theta, and static friction maximum can be substituted by nu sub s. The normal force can be substituted by mg cosine theta, giving us this final equation. mg cancels from both sides of the equation and cosine theta is divided from both sides, giving us the tangent theta equal to static friction coefficient, which we use to calculate the static friction coefficient with the angles we measured during the experiment. Substituting mg for n and tangent theta for the static friction coefficient back into the static friction maximum equation gives us Fs max equals mg tangent theta, which was used in our calculations. In conclusion, these results would be what you expect. Asphalt had the highest maximum, while tile, a less abrasive surface, had the lowest maximum. This explains why you are more likely to slip on tile than in a parking lot.